I'm Colin Lee. I'm an Android developer. I would have told you like last week that I worked at Mintermate, and I still do, until about a week from now I'm starting at a startup called Bitcoin. Both very exciting companies. They're both hiring, so if you like either Mintermate or Bitcoin, they're for engineers. I do Android. I've been programming on TRS-80. They were sold by Radio Shack, so I don't know if anyone remembers those places. They just went bankrupt this year. Race cars for fun, like electric autos, that kind of stuff. So let's talk about why reactive. Well, what does reactive solve that's a problem? Well, we all remember back 2005, I think, you know, some of us were in grade school, but some of us were actually programming back then. And we remember that there weren't a lot of threads that you usually had to deal with when you were writing your program. It was mostly, everything was single-threaded. Your UI could just, you know, flow in a sequential manner, and you didn't have to worry that stuff would get farmed off and get lost or messed up somehow. And another thing we're seeing is a massive growth in cloud computing. So what's happening is not only are we seeing more threads now that are getting difficult to manage. You know, people have lots of things they say about threading. In addition, now we have this problem that we have to go out, reach out to the cloud, which can take, you know, 500 milliseconds or some ridiculously long time sometimes to get something back. It's very unpredictable during inclement network conditions. So now not only do we have the thread problem, we have the latency and network problem, and we have to solve both of those. And to top that off, if you've ever done threading and done it yourself, all custom, and done it in a synchronous manner, you know, where you're basically writing imperative code, there's a lot of really, really hairy problems here. You know, I mean, just blocking alone in core Java, there's all kinds of things from semaphores to reentrant blocks to countdown latches, and you'll get a billion answers for how to just solve that one problem. But then you've got all these things. And if you're dealing with Android, you're probably dealing with like async task or async loader, which has so many problems, you know, that most experienced Android developers will just tell you not to use them. So a lot of these problems, you know, error recovery, you know, like lifecycle events, these things are all solved by switching to something reactive that will deal with problems one at a time on the correct thread. So existing solutions like async task have a ton of problems. I know, for example, try canceling an async task. You may be 50-50, it may work, because if something is actually running on a processor, it will wait until it finishes that statement to check and see if it should cancel. So with async tasks, a lot of these things you can get memory leaks if you're actually create your async task as an inner class within another class, which a lot of new programmers do all the time. It's something we always see when we pick up the legacy code that somebody else wrote, is that everyone uses async tasks wrong, that they're scary, they're a mess. Yeah, all these things are bad, and there are things you have to deal with and can be done better with reactive programming. So as Reactive says, complexity kills. He wrote this memo back in 2007. That complexity sucks the life out of developers. Threading is complexity, and the way that it was in 2007, he said it's going to bring us down as a company, and put out this memo to all his developers and trying to get ideas. And one of those ideas came from this guy called Eric Meyer, who we'll get into in a second. Ray Ozzie, by the way, also the guy who founded Lotus Notes and headed up the Microsoft Outlook division at Microsoft. So how did reactive happen? It's not the real Gang of Four, but I like to think that's the. For programmers, after blowing up the car, and unfortunately, not really, published a list of the most useful design patterns back in 1994. And there were lots of really awesome, useful design patterns. You can read the book, no one ever does, but it's good to actually know the patterns in the book, if that's possible. The observer pattern is one of the most useful ones you see all across programming. There's lots of, you're all talking about factory and other when it comes to threading, the observer pattern really solved a lot of problems for me. So that was kind of a first step in this process here. And then along came FRP. Now the thing about functional reactive programming was it never took off in the mainstream. It still kind of hasn't. It was an academic paper in 1997. Started in like Haskell. Wonderful ideas, really cool, and it would be great if it was something that could apply in a way that is the way programmers write software, which most people aren't using functional languages. Aside from financial services, defense, and maybe one other industry, you don't see a lot of like Haskell and Scala and Lisps in most, although they're gaining popularity these days because of threading. So functional reactive programming solved this problem by representing the data in their programs. Every single variable is nothing more than an event stream, an observer pattern of data plotted as values over time. And it had this concept of continuous time where you could see at any moment in time exactly what the value of every variable in your program was. This is so cool. Now, if you go to my mini-bar presentation, it'll be a lot of the same stuff I'm doing here today. But I'm also going to talk about Elm, which is an FRP language. Because of continuous time, you can actually time travel with the debugger, go backwards, change things, go forwards, and see what the result would have been. And you can't do that in any non-FRP language I'm aware of. So this stuff is incredibly cool, it's academically awesome, but actually writing the code is very difficult because in functional languages you don't have variables, you have immutable values. You don't have loops, you have maybe signals, and you don't have, the point is, it's very confusing for people who are used to writing in Java, C# or another imperative language, which has all those fun things that we've grown used to. But one of the key ideas was that event streams are superior to state. We don't want to have to hang on to state variables and maintain them, and there it goes again, that's just my screen. Yep. We don't want to have to sit there and maintain state variables for our whole lives and make that what our job as programmers is about. So, moving on from FRP, along comes this guy, Eric Meyer from Microsoft, reads Ray Ozzy's memo, and he decides, hey, let's implement something for C#.NET based on these FRP ideas, and that's going to be RxJava, the first reactive extension library. So one guy leaves Microsoft, joins Netflix, named Jafar Hussain. He and Ben Christensen ended up building RxJava thing, which is basically a straight port of Rx.NET with some new ideas. Very simple. And they end up using RxJava to build their middle tier. I mean, it's the reason why Netflix is so reliable in spite of deliberately crashing their own servers. And this happens. This is called the Chaos Monkey, and it's a cool topic to read on later. Anyway, so who uses this? We just mentioned Netflix. So Netflix says that we're a big believer in the Rx model because Rx has made it easier for us to build complex asynchronous programs. They say it's effective on the server for us, spreads deeper into the code the more we use it. New York Times, so they're using it both on the server and on the mobile end. They say, as things get more asynchronous, functional model, which is what our RxJava is using, fits very well. Chaining and transforming async operations, powerful tool, very awesome, right? Microsoft, obviously. If asynchronous spaghetti code were a disease, Rx is the cure. So, lots of big names. GitHub, they rebuilt their entire desktop apps. Both of them, they actually created a reactive Cocoa specifically because they wanted to use the same things they did for their Windows code on Mac. So GitHub was such a strong believer in it, they spent all this money on open source and building their own thing. Beautiful. They love the testing, they love the error recovery benefits, and everybody's using it. So, just a few companies that are using RxJava, or Rx. So let's talk about what observables are and how it differs from the observer pattern, which how many people know the observer pattern? Just get a show of hands. Okay. I may have to go over it a little bit. So, in the observer pattern, you have an observer, and you have the thing it's observing. And whatever the observer is observing, it emits events that the observer then processes one at a time. And this is similar, however, it adds a few more concepts. in object-oriented programming, you only have events in the object-oriented pattern traditionally the way it was written back in 1994. But with observables, it also handles errors in addition to events. It can take a completion signal, and the events are composable so that you can actually filter, chain, combine, and map these streams to other types. Now, you already got a little bit of exposure to this just briefly in Dan's talk, where he showed you mapping one type to another type. I'll get into this in a little more depth. So, move on a little. So, if you know Java, you probably know what a future is. You may not. You would probably know what an iterable is, or at least a list, which is a type of iterable. An observable is nothing more than a list of futures. It's an iterable future. If you're used to JavaScript, you might call it a future a promise. They're actually nearly identical. The definition is so ridiculously close as to be not important, actually. So observables fill the gap by being an ideal way to handle asynchronous sequences of multiple items, essentially a list of events. By the way, a future or a promise is basically a handle to a future value that you'll receive later. This is a way of like grabbing a list containing all of those values in the sequence. So observables also offer an alternative to state variables. As programmers, we hate having to hang on to state variables too much because what happens is you forget to update it at one point, and then suddenly your whole program breaks. And this happens all the time. It's probably one of the main causes of programs breaking, especially when you've got very complex threading going on. So the reason why we don't use so many state variables when we have reactive observables is because if our code gets subscribed to at the very end of the observable chain, we already know exactly where we came from. We know every set of steps it took to get to where we're at. We don't have to go hanging on to, did I go through this network request? Did I come from this UI? We can see at the very end of the chain where it all came from. And that's why we need fewer state variables. Make sense? Callback hell. Who knows what callback hell is? Anyone? I heard some ucks in the back there. Callback hell, if you're used to JavaScript, a lot of people visualize it as deeply nesting logic around callbacks. So you would put one callback inside of another callback inside of another callback to be able to handle situations that happen after a chain of events occurs. You don't need that at all once you get to reactive programming because essentially every chain is its own separate thing. You don't nest them inside of each other. It makes things a lot easier because JavaScript callbacks where you're nesting them deeply, going from left to right on the screen, where you're indenting a lot, that's hard to read. And a lot of JavaScript programmers tell me that you've solved that problem when you name the callbacks and you're no longer scrolling to the right. But that's not really a solution. If you name your callbacks, suddenly you're jumping all over the program. You know, by having a chain, we know exactly where we came from, we know exactly where we're going to, and everything is real. Whereas if you're just doing named callbacks, the logic becomes nonlinear. Now we just have to go, playing, follow the white rabbit to get to where the code went to. So, callback hell is solved by using reactive programming. By the way, I gave this talk in San Francisco at DevCon, and I had 2.5 hours, so I'm kind of like, if I feel like I'm blitzing through this, feel free to ask questions, because I had to cut this down to 50 minutes. So, breaking it down, simply put, the results of an asynchronous operation can be treated like an array of events ordered by time. That's what our observables are. You can have an observable that takes 0 events if an error occurs right away. You can have it take many events, like say an event bus, or you can have it just take only one event. Say you're expecting one response to a network request. You can just wait for that one event and then complete your observable. So it doesn't care about how many events there are. It can be used for simple network requests. Just making that clear. Composable, what does that really mean? It means you can take a whole array of functions like this filter function here. Let's say I only want events where x is greater than 5. I can just chain this on the end of my sequence, and it'll, the same way you array, you can do it with an observable. When the event arrives, if it's greater than 5, it continues down the chain. If it's not greater than 5, it doesn't go any further. Immutable. This is one of the common mistakes I see with observables. Is sometimes when people are just trying to figure it out, they will attempt to just say like observable about first to get the first item in the observable, like when they're printing out results. When you use these composable functions on your observable, you are not altering the original value in any way. What you're doing is you're returning a new observable. And until you subscribe to it, you're not actually doing anything with the result. And I hope that makes sense. So every operation you perform returns a new observable when you're going down the chain. And if you've used builders, builders are also immutable. And that's exactly the same kind of thing. You just chain things one after the next, and then you do the build at the end. In this case, instead of build, it's called subscribe. Subscribe is the actual work. So when you're working with reactive programming, everything is a stream. And what you can think of as being an array of events can be an observable. Click handlers, event buses, network requests, database requests, input dialogues, list adapters, any variable can be an observable. And in FRP, most FRP languages I'm aware of will actually treat all the variables as if they're observables, essentially. So literally anything in your program can be an observable. But it doesn't have to be. One of the great things in here is you can use it exactly where you need to use it in a narrow circumstance, and then have the rest of your program look like normal. Awesome. So I'll briefly touch on subjects. I don't think we use them as often because the thing about subjects is that they're input and output, whereas observables are only output. If you're doing like a network request, you probably are going to want an observable. You just care about the results. You don't want to inject things into it. But there are times when you are going to want something that is both input and output. And so things like binding your model with the view, event buses, or wrapping observables. Those are 3 great examples where you might want a subject. Right? Yeah, they break the functional programming contracts. So if you don't need a subject, you should use an observable. You don't actually need the input piece of it. And the next slide is on the same thing. I guess let's keep going. Anyway, so there's 4 kinds of subjects. I'll just kind of breeze over this because you're not going to use a whole lot of these. Async subject only cares about the last value emitted. Doesn't return anything else. You've got the behavior subject. This one's very useful. Like say you're making a video game, you only care about the most recent health value for your character at the moment. When you subscribe, you want that value, but then you want everything after it. That's what you would use for that kind of thing. Published subject is actually usually, I use this for event buses. It's great for event buses. If you're using RxJava in your code, there is no reason to include auto under any circumstance. This does everything as good and maybe even better. So published subject is your event bus in RxJava. And replay subject will replay everything. It's a great way if you want to actually care about all the values up to a point. So let me get some code here. Well, we'll look at the operators first. So map you already saw. This converts the type of one event into a new type. You can convert a string to integer, for example, on every item in your observable. That's map. Flat map is a little more complicated. Essentially, you're converting type, but you're also flattening, which means that while one event could be like an entire list of events, you can convert it down to just one single observable, rather than being an observable of a type. So that's a little confusing. I can explain better. Filter we saw as well. This is a simple Boolean. If x is greater than 5, return continue down the chain. That's all it is. Very simple. I'm going over simple operators right now because I kind of want to just talk about these initially, like the example I'll show you. So the take, these marble diagrams are great for explaining these things. Take just takes the first few items. There's also ones to take the last items. There's ones to take middle items. But example of just saying, I only want the first few. If you're using Netflix, actually, this is how they determine what movies to show you, is they'll do a score for every single movie on your queue of how much you want to watch it, they think. And then they'll say take 10 or take 30 and show those. That's exactly how they're doing it. So, RxJava examples. Let's take a look into my Fibonacci example. I'm going to leave that up for a few seconds so people can, if anyone wants to grab the URL, give me about 30 seconds. Yeah, I can't bring it up myself. Already. Everybody, how are we doing? 40 minutes? All right. We cool? Okay, all right, so let's go take a look here at this Fibonacci example. Look at your studio. All right. Oh, that's not good. 1 second, guys. Cable's a little short, that's my problem. I'll work down here. Okay. Sorry about that. Maybe we can actually make that text a little bit smaller. Let's just scroll down a little bit. Anyone know how to change the text size in the presentation?
Command plus and minus.
Try command plus minus. See scrolling. I can just go back to regular. There you go. We have to do it this way. Yeah, it's big enough. I can read it. Okay, so looking at some comments here. So let's just take a look at this code here. This is actually the code that's doing the work, right? So we're going to generate a Fibonacci sequence. I'm going to use big integer because we actually, if you do Fibonacci out to any decent number, you're going to run out of integers that are within 32 or 64 bits. So what I'm doing is I'm creating an observable here of big integer, which is just a type that can handle really, really large numbers that are integers. Okay? So I'm taking n being the number of times 2 Fibonacci, and I return a new observable that I create. And here's the core code that does it all. So observable that create allows you to explicitly make calls to onNext, onCompleted, and onError. Those are the 3 functions of the subscriber. Remember how I said the observer pattern essentially only takes events. That would be the onNext in this case. This is adding in onCompleted and onError. And one of the beauties of that is later on, if we have an error, we can actually handle it up here in a way that it falls through to the bottom, and we only have to do error handling one time for our entire observable chain. Okay. So right here, I'm just initializing basically a tuple, and then I'm just creating a new event for every single tuple I create. Does that make sense? So I'm just running through a loop from 1 to n, and then creating events. And then when I'm done with the loop, I can call on completed, and I cache errors down there. That's all there is to it. Very simple code. But we can subscribe to it up here, and we can use all these composable functions to manipulate the results of this observable. I'm just going to run the app, make sure I'm running the right one. That'll do. And it's a Java app, not Android in this case, so it'll just run really quickly. So he doesn't have to go out to Gradle and download too much. Yeah. So, does anyone have any questions so far about what I'm doing here, code-wise? Anyone? Okay. Yeah. Well, it's gonna compile for a little bit.
I have a question about the syntax on your print line. What is
My
that?
print line.
The
Oh, yeah,
syntax.
that's, okay, so I'm using a lambda there. And that's actually, it's just shorthand for basically saying, you know, new lambda, and then call system out print line on the results of the value going into the
So you're
lambda.
using Java 8 there?
I'm using Java 8. This is
Okay.
retro lambda I'm using.
Yeah.
It kind of simplifies the code, but it can be harder to read sometimes because it doesn't show you types visually. You would have to like see a mouse over to see a hit, type hit sometimes to see the types. But this print line statement is really printing the results of each item in this case, where it's describing. And I'm shocked this is taking so long. Normally I run this thing and it's like, you know, snap and it's running. Probably trying to get out to, what is it, right now. Maybe Wi-Fi is screwed up. Sorry guys. I don't think it's working. There we go. Get the results. So I just ran this again. See, this is the first 100 entries in Fibonacci sequence. So it starts from 1 over here, goes all the way up to the 100th Fibonacci number. That's very simple. There shouldn't be anything wild about that because I'm actually just running a loop and then iterating over the observable. Nothing crazy there. I just wanted to show you some of the composable operations that perform on this. Keep in mind that while I'm showing this example, you can actually use this on more complicated things like network requests that are obviously very asynchronous and more complicated. So let's say we just want the first last 2 results that we missing. Like this, I would go .print last. I'll type it in here. So now this time when I run it, I'll run quickly at it, I think. And this operator is going to say, just give me the last 2. I sure hope this runs quickly because I don't want to have, there we go. As you can see, I only got 2 results of it back this time, the very last 2. That'd be 99 and 100 Fibonacci numbers. Got it? So I can do that. I can combine and chain these guys in particular orders. Let's say I want to pick a certain element. We'll do the 95th Fibonacci number. Crazy. Pick anything you want. So like I said, the way you might use something like this, if you just do like take 10, you can use that, say that would be a top 10 list, you know, of an entire sequence. And then there's the 95th, I said, yeah, Fibonacci number. So this stuff's not too impressive at this point. We're just showing you like, I can obviously filter. So let's say I want to filter for n is greater than 1,000. Oh, big integer. Big integer, man. N greater than. Figure out what operation I gotta do. What is it? GT? I would think GT would be. Yeah. Let's do something else. I'm going to show you math. Math. I'm going to say math from that. So instead of object, I'm going to say integer. Big integer. Value. And then I can now it's integers. Now I can just say dot filter x where x is greater than 100, 1,000, whatever. And hit run, and we're going to overflow, so it's going to give us some really crazy results. But that's the nature of dealing with integers when you're doing really big numbers. So as you see, it overflowed. These are all numbers greater than 1,000, but it's after overflowing that we ended up with these numbers. That's because I just mathed. I'm going to show you the code again. Yeah. Should actually change these things so you can read them. Map, filter, subscribe. This is all I did. I said map from big integer to the nth value. I said filter for values greater than 1,000 and subscribe. So this isn't that crazy or sexy or any of that stuff. So we're going to take an example that you might actually use in your application. These are all just showing you how it works kind of thing. Let's take a look at what's called debounce. So I'm going to actually run this on a phone first so you guys can see it. There it is. 1 second. So we're going to mess with the Google Local API. Who's used the Google Local API? Anybody? No? Okay. What I'm going to show you here is autocomplete. You guys have used that before, I'm sure. In this case, RxJava provides those composable functions. Some of those functions are related to some of those functions are related to sampling something or only taking a value after a certain amount of time. That's what we're going to do here. So we're going to use, just go ahead and hit OK. 1 second. We'll blow this guy up. Right screen. Magic. Assuming I can get out to the internet. Showing me like half the screen on my phone. Oh well. What kind of business do you want to look up? We don't have a favorite restaurant in town. What is it?
Meat door pub.
Let's see, is it getting out to the internet? I'm not sure it is. My Wi-Fi might be down. Please set here. Very good. Okay. I gotta look and see if we're getting an error. Oh, API key is invalid. Sorry about that. I think I have the API key I put in. It's actually my GitHub API key, and I got to put the Google one. Hang on, I want to be able to show you this thing, but anyway, I'll just explain it. I used the wrong API key. I used my GitHub API key where I was supposed to use the, what do you call it, Google Local API key. So what happened? Anyway, so what happens is you type in the actual name of the business in this case, and it waits a period of time. After each character you type, you don't want it to go making a brand new network request. So what RxJava will do, and I'll show you the code, is that it's actually going to wait a period of time, and then only if you haven't typed in that period of time will it actually take the value and then go off the internet. So the actual code is right down here. Sorry?
The delay time unit milliseconds?
That's just that's in milliseconds right there. So here, let's start here. So search text observable in this case is actually creating an observable from the view, the edit text in this case. And so we're running this operator called debounce. Debounce is the operator that's doing the magic for us. It's actually, for 500 milliseconds, it's waiting before it actually makes a network request. And it checks to see if that edit text that view observable right here, edit text, it wants to see that we're not still typing. And after 500 milliseconds, if we're not still typing, it's going to go ahead and then go through this sequence of events on the chain. Now you'll notice one thing that's important here is observe on main thread. If you're writing code for Android UI, you're always going to want to observe on the main thread because you want your results to show up in the UI. And you're not allowed to do that from any other thread but the main thread, right? So what we're doing is we're going to map from the edit text to the string results of what's in there. We're going to flat map, in this case, to go by going out to Google Places, grab the results, and then observe it. Basically this comes up with a list of strings and displays them in a list view at the bottom. If I had written this thing a few months later, I would have written with the recycler view, but this was written back in October, so. So does anyone have any questions about this? Yeah, I'm sorry I couldn't show you the live demo. Pulling up the API key in the middle of my presentation will probably take too long. So I'd be glad to show you. It's all on my GitHub, by the way. The reason why the API key wasn't there is because my laptop would stop booting on Friday at the end of the day, and I had to download everything off GitHub and kept all my API keys I had to get ignore, so I wouldn't accidentally put them on GitHub. So yeah, anyway, that explains it all. Let's look at another example. I got one more here. This is a GitHub example. And this is good. I'm trying to get a little bit crazy here to show you what you can do. This is combining, again, that last one was retrofit along with RxJava to get the request from Google. So what I'm going to do here, this is a network service. It's going to go out to just running, see this interface here? This is super simple. This is all that it takes for retrofit to know how to go out to GitHub, grab a list of gists. And there's a second request, go out to GitHub for a particular gist, grab an observable of gist detail, which is a pojo I created myself. I can show you that if you want to see it. It's pretty simple. Gist detail is like that simple. That's all there is to it, right? An iter, a setter, and a map. That's it. This file is also, that's simple as well. So, moving on from the interface, if we scroll down here, this is just setting up my retrofit client. It's all boilerplate like Dan showed it to you. We get down to here, this is the magic that's doing all of the network work for this. I should show you what it's actually doing. I'll run this and this will actually work. So, in GitHub client.gist is calling that retrofit interface we just saw. The thing is, if you write Java, you know that interfaces don't contain any actual implementations. So if you use retrofit, when you pass an interface, it is creating the implementations of each one of those functions for you, for your REST client, right? That's amazing. That's really, really convenient. It gets a lot of work done for you. So GitHub client.gist is returning an observable that then we're going to chain. We're going to flat map it with observable.from. What this is doing is GitHub client.gist returns a list of gists. And we want to look at each individual gist in order to download it. So we're going to say, well, take that list of gists, turn it into an observable where each individual event is one gist. That's what flatmap is doing here. Got that? Take two in this case is saying we only care about the first two gists. Cache is saying don't go back to the network further down the chain to grab any more. So group by gets a little crazy here. What we're doing is we're saying, for each gist, let's split them out by ID, and we can combine them later down the chain. So, okay. We get this because we flattened. We need to actually group them here, and then we're. Let's see if I get this right. Yeah, it's been a while since I looked at my code. Okay, so again, flat mapping in order to get the actual gists text, and then we're going to timeout with that easily in one line, retry with one line, put it back into a list, and then send it up to list view. And I'm going to show you how that works. And this one is going to work for me because I actually put a GitHub API into both applications. This one will actually work. Knock on wood. All right. Let's take a look at the. Okay. So as you can see, the first gist is rickrolling you. The second gist is actually a code I was showing someone else on Spice. And this is all being pulled live off of GitHub's gist service right now. And if you want, I can totally change whatever the first gist is and we can show that it updated. But it's just pulling from GitHub. Cool. So again, like looking back at the code here, I might want to explain this a little better. But that's all it took to do that. I mean, instead of take two, I can just go ahead and have it like show you everything in my Git just that easily by taking out one line. I'm just trying to give you an idea of how useful this chaining is right here. So one thing to keep in mind though when you're writing RxJava is unless you set observe on and subscribe on to particular schedulers, it's going to run synchronously. So you're going to want to set these guys. Otherwise, the stuff is pretty easy. One other thing that everybody wants to know about as soon as they see this is how easy is it to test RxJava? I mean, this looks kind of crazy simple, but then is the testing picture more complicated? And actually, it's easier because if you're writing things asynchronously, how difficult is it to take traditional imperative code that would do the same thing as this and make it so that for every, and recreate a race condition by setting the timing of each individual event that happens. With RxJava, all I have to do is I set a scheduler called a test scheduler, and I can say for every tick in time what I want it to do. And it'll reproduce that in the test on the fly right away. And it does it reliably 100% of the time because you're just simulating a real scheduler. Exactly the way your code normally would. You just swap one in here and set the main thread, you might put another scheduler. So that's how testing goes. It's actually, if you use Dagger and you use RxJava, testing is a breeze for any asynchronous app. Does that make sense? Cool. Does anyone have any questions? I know you have. Here you go.
Can you explain the group by? I'm having a hard time wrapping my head around what it actually is doing, or what it's outputting.
Group by is splitting the observable into multiple grouped observables at that point. It's kind of a crazy concept. There's really two ways. Well, so what's going on is I'm trying to take. Can we get this going to sleep on me again? Oh my God.
Okay, that wasn't just me.
It's like I go to the GitHub client again. And the GitHub client.gist up here is grabbing the particular gist by string ID. And what I'm doing, the reason why I'm doing the group by is I want the ID in order to request each individual gist. Right? And I think there was a deal where multiple gists can have the same ID or something. So I'm trying to flat match it down to a list of just the IDs of each gist that's there. If that makes sense. And so group by is all about splitting the observable into multiples and then you can access their key to use observables of a certain type that fit in. That way you can access each observable separately within the same chain. It gets a little complicated, I won't lie, but if this is complicated, the one thing with network requests is that you can do with RxJava very, very simply. The reason why I used it in the first place when I was starting to look into this is chaining requests is super, super, super easy. Putting one after the next. And binding request is really easy. You can take two network requests that return different types and use observable.zip. And then that function inside observable.zip will combine the results into a new type that you can pass further down the chain. And so at that point, I can put observable.zip, and I can pass it down the chain, and I can have another network request fired off based on the results of the last 2 or 3 that already were done simultaneously. And it doesn't matter what order they come in at, it just handles them. It grabs the first event from each observable that occurs. And that's all it does. Does that make sense, guys? I keep saying that. Did I answer your question?
Yes.
I think I could have done better, but group by
Well,
is a little
just for clarity, that group by, what actually is coming out of that are multiple observables.
correct.
And those each observable, it contains potentially multiple items.
Correct.
But in this case, there's only 2, so.
Right. So what's happening though is flat map flattens whatever you pass into. So I'm actually going out there, creating multiple observables, and then for each one of those multiple observables, each observable, I'm creating one network request, and then I'm mapping it all back together into one observable again. And it makes sense in this particular flow, but I'm trying, since I wrote this so many months ago, I'm having a little bit of like cognitive dissonance about why I did some things. But I had a very, very good reason for group by in this case. In fact, in my mind, I was thinking I was going to use observable.zip because that will do the same thing in a lot of these cases. But this was a simpler implementation than doing it the other way. So when Dan said that sometimes RxJava is a little bit hard, what he's talking about is there's so many different things you can use in the chain, so many different ways to do the same thing, that you have to kind of like start getting your mind wrapped around what's out there and what the best way of doing something is. So the basics of going out to the network and handling the threading coming back, that's easy and everybody should be using it right away. But it's worth asking questions, you know, talk to people who know RxJava, and we'll all kind of try to help you out. I mean, we're all learning this at the same time. Netflix only created the library less than 2 years ago. And people like Dan and I are becoming like experts who are, you know, known for like helping other newcomers to the language. Ideas that came from RxJava less than a year ago are making it back to all the 15 other Rx implementations in other languages. So there's some brilliant ideas coming out of this Android work with Java that are being applied across the entire, you know, industry space, in Microsoft and .NET and JavaScript and all over the place. So, yeah. Any other questions? Come on. I know someone's got something glaring or burning. Because I gave the same kind of talk, I said, in 2.5 hours in San Francisco, and one person was completely still like in a haze at the end, you know, didn't understand. And don't feel bad if you don't understand something. Anyone? Okay. Still have another 10 or 15 minutes, so.
Did you compare Spring Reactor with RxJava?
Can I what?
The Spring Reactor with RxJava. Spring also came up with the reactor.
Oh, Spring also came up with the reactor. I haven't used Spring's reactor. I do know they have their own networking library too that competes with retrofit. I haven't used it, so I can't speak to it really.
Did you try the scheduling capabilities in RxJava?
I have used all the schedulers in there. Well, 90% of the schedulers, I'm sure. There's probably some I haven't touched yet. There's going over each and every one of them could take a while. But the ones I normally use, Android main thread is custom for Android. It's very, very useful. You saw schedulers.io, a couple of examples. Sometimes the trampoline scheduler is useful because that'll then take the results and make sure they stay in a queue coming back to your program. I might use that in a service where I don't care about the main thread, but I still want things to occur in a certain order. Yeah, there's a lot of schedulers, but there's only about 6 that you regularly use, I think. Maybe less. Yeah, go ahead.
Sorry, my brain was just thinking, I don't know if you were done, but I have a totally different question.
Okay.
All right. You know, it's interesting because like back when using like async task, this was still an issue, but because of observables, like when you end up consuming like a retrofit endpoint,
Yep.
you know, you'll see right there in the consumption code, like perhaps accessing properties of the activity or the fragment or something like that. And of course, if it's been collected or if lifecycle methods has happened, the activity might be null.
Right.
And I guess what I'm wondering is, have you come across a good way of making sure that, you know, and this is the same, I mean, like it's the same thing as like what you might do for any other sort of callback or whatever, but it just seems like observables make it much more apparent, like you're running this code, but your activity might be null. So like, is there a way to make sure that you're not going to crash your app in
Well,
that?
The easiest way to answer that is what I always do is you can bind your observable to an activity. In that case, when the activity goes away, you're no longer subscribed, none of the callbacks ever occur. That's the easiest answer. You can also do the same thing manually without using any of the Android-specific callbacks. You can say in on pause, unsubscribe to everything.
Oh, okay.
And there's something called a composite subscription that can collect all your subscriptions together so that you don't have to unsubscribe one by one.
Hmm.
That saves you also from memory leaks.
Yeah, right.
That's another, anytime you see a new paradigm, like object-oriented programming, when object-oriented programming came out, people were all thought it was scary. Any new paradigm has its downsides, and you're not going to get away from those unless you understand the new paradigm you're moving to. And that's, so one of those things is always unsubscribe. Always keep a handle to every one of the observables you create. Don't just let it, don't ignore the return value. Okay, that's one. Another one is always use an on-error. I actually broke that rule in my RxJava example. Always set on-error to something so that you can handle the errors coming back. I'm sure people write code sometimes where they forget about that. I think those are really the big two ones for me. Don't ignore the return values. Unsubscribe and use an on-error. That's basically it. Yeah. Handling errors, good one. Thank you. So, in this particular code, I'm currently just throwing a stack trace right here. So, subscribe takes 3 callbacks, right? The second and third are optional, but you should always use the second one. So, first callback is what you're going to do when you're observing the results that come back, and that's in case it's calling my display files function, right? The second one is what do you do in case of an error. Right now I'm just printing a stack trace. The third function is what you do when the observable completes. So say you want to do something when you're done with the entire sequence, you would then put another comment in there and throw in a third callback in that case. So the great thing about error handling in RxJava that's different than basically every other way we've done it before is all the errors that happen along this entire sequence. If you ran a function in flatmaps, if you ran a function in your filter or anywhere along the way, if any error occurs, they all fall through down to the bottom, which is good for you because you don't have to rewrite the same error handling functions or reuse them, not know where you were coming from at any point along the way here. You just handle it in one spot and you just look at what kind of type of error it is and handle it right down here. And it all falls through. And the other thing is, if you're writing the error function here, you know exactly where you came from. You don't have some generic error handling function somewhere that doesn't know where it came from. It came from up this chain. And you can have more than one chain that